Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So, without further ado, I'm very happy to introduce the Stop and Frisk group. The first speaker, Siobhan Wilmot Dunbar from Pace University, followed by Derek Sands from Brooklyn College, Afzal Hussain from City Tech, and Hannah Pugach from Baruch. Please join me in welcoming them.
Good evening, everyone. Tonight we will be presenting to you an empirical analysis of Stop and Frisk in New York City. The Stop and Frisk program has been quite active in New York City for some time, and the basic procedure behind the program is that if a police officer sees an individual that he or she deems to be suspicious in any way, then that officer has the right to stop, question, and frisk that individual at his or her discretion. This program has many potential benefits, such as creating an atmosphere of safety in society and reducing crime. However, annually, about 500,000 people are stopped, with only 6% of these people being arrested. That means that 94% of people that are stopped are presumably innocent. That's hundreds of thousands of innocent people being stopped every year. And stop rates are also disproportionate across various demographic groups. For example, 87% of all stops are made of Black or Hispanic individuals, while there are only 53% of Black and Hispanic individuals in the population. So that means that there are more stops of these people than there are people of that demographic in the population. And the legality of the Stop and Frisk program has often been argued, such as the violation of 4th and 14th Amendment rights. But no one really looks at the social cost of this program, which is the burden placed on innocent individuals in society, innocent being those who are stopped and not arrested, which is again the majority of those who are stopped in the first place. Our research focused on two main parts: the social cost, again the burden that is placed on all of these people who are stopped and not arrested, as well as ways that we can improve the way that stop decisions are made, which we looked at with two different types of models. So first, we'll focus on the social costs. In order to measure the social cost, we have to look at the stop rate. And once more, we focus on the stop rate of those who are innocent, because the majority of people who are stopped are presumed innocent at the end of the day. And we calculate the stop rate by dividing the number of stops of innocent individuals by the total number of people in the population. This is also known as our yearly per capita stops, which is the estimated number of times that someone is expected to be stopped in any given year. And we estimate these stop rates for each demographic groups broken down by age, sex, and race. In order to calculate our stop rate, we use two main sets of data. First, we looked at the Stop and Frisk data obtained from the New York Police Department, which gives us the recorded number of stops. And between 2006 and 2012 alone, there have been about 3.8 million stops. We also use the census data, which has two main parts: the PUMS data, which gives us detailed individual population data, and the block level data, which gives us this detailed information also by location. So for the purposes of our stop rate, we focus on the Stop and Frisk data for the number of stops of innocent people, and the census PUMS data for the total number of people in the population. And here we have a plot distribution of the yearly per capita stops, once more the estimated number of times that someone is expected to be stopped in any given year, broken down by the ages of those who are stopped recorded in the Stop and Frisk data, separated by males and females. And we can see that females have a drastically lower stop rate than males, but in both sets, Black individuals rank the highest of all people who are stopped. And if we look at the highest ranking group of those who are being stopped, we can see that 19-year-old Black males rank the highest with about a 1.2 stop rate. So that means that if you're a 19-year-old Black male, you can expect to be stopped at least once or more every year. And since Blacks and whites are so often compared, if we compare this to a 19-year-old white male, we can see that an individual of that demographic is only expected to be stopped about 0.2 times each year. So that is a big difference in stop rates between these two racial groups. And let's not forget our females. If we look at 19-year-old black females, they rank the highest among all females who are being stopped, and they have only a 0.06 stop rate each year. So this plot gives us a visualization of what the social cost of the Stop and Frisk program is and helps us to quantify that. And we can see that this is the social cost, the burden that is placed on all of these individuals who belong in these demographics and are being stopped so often every year, but are presumed innocent at the end of the day.
Good evening. This is a random sample of 10,000 stops from the Stop and Frisk data set. Each dot is a stop recorded from that data. And as we can see from the map, there are some locations where there are more stops than others. And so what we're going to do in this part of the talk is quantify how much location affects the stop rate for certain groups. And to measure the stop rate by location, we created a grid of 1 kilometer by 1 kilometer squares, where in each square we have the number of stops for a certain group as well as the number of people that live in that square. As we just heard from Shaban, we see and know that certain young males are being stopped more than others. And so what we're going to do is focus on young males that are being stopped, differentiating them by race. And so here is the stop rate for young, innocent white males. Innocent for us will mean that when they were stopped, that stop did not result in an arrest. Young will mean that they range from the ages of 18 to 29 years old, and stop rate again is that it's the number of stops in proportion to how many people in the population. Gray squares are where the stop rate is less than 0.25. And so we can see that as where a person is less likely to be stopped. The highest stop rate for a young innocent white male is in Coney Island at 0.5, which means that on average, they'll be stopped once every 2 years. These white empty spaces are where fewer than 100 young white males live. And we use 100 to be more accurate with our stop rate calculations. And here's the stop rate for young, innocent black males. We can see that there are very few gray squares and many different shades of reds and oranges. The highest stop rate for a young innocent black male is 3.2 in Jamaica, Queens, which means that on average they're going to be stopped more than 3 times in a year. Okay, 15% of all stops made by NYPD are made in public housing buildings, and while 7.4 of New York City residents live in public housing buildings. And here in Brownsville, Brooklyn, 4,000, they average 4,000 stops a year. And of those 4,000 stops, 3/4 of them are made in public housing. And here's the stop rate for young, innocent Hispanic males. A few more gray squares and less intense reds. And here's a side-by-side comparison of the 3 groups, along with the average stop rates. And the average stop rates for a young Hispanic male is around 4 times as much as a young white male. And the average stop rate of a young black male is around 8 to 9 times as much as a young white male. And to recap, as we heard from Siobhan, the number of stops of young black men exceed the number of young black men that live in New York City. And the number of stops of just young males in certain neighborhoods exceed the number of young males by several times. Thank you. Thanks, Sherrod.
So as you guys can see, there are some negative effect of stop and frisk in our community, especially community of colors. So the question is, how can we make the system more effective without sacrificing the stop and frisk, the benefit of stop and frisk? In order to do that, we create two models. First one is full statistical model, and another is heuristic model. So I'm going to talk about the full statistical model. So this model will help us to answer question, how can we make better stop? So first question is, what do you mean by better stop? So better stop means stop the criminal, not the innocent people. But there's two questions that we have to answer here. First, who is a criminal? In the real world, if someone gets arrested, doesn't mean that individual is a criminal until they've been proven guilty in a court. But in our case, we use arrest as a proxy. So if someone gets arrested, we assume that individual is a criminal. More harder question to answer is how you know ahead of time that individual will get arrested or not. So NYPD is using some sort of checklist as their guideline to stop people. So if you remember from Siobhan that hit rate was around 6%, which is better than if they would just stop people randomly. Here's a picture of stop and frisk form that NYPD use after they stop someone. So there are around 20 reasons here. So if you pay attention to this reason, suspicious object, report from victims, carrying object in open view, used in commission of crime, these are really subtle points, and this really makes sense. If they stop people for this reason, it really makes sense. But on the other hand, there are reasons like furtive movement, which is totally unclear. I mean, what do you mean by furtive movement? And it is very easy for an officer to misuse that. So we're going to build a full statistical model that will help us to see what reasons are more predictive to arrest. So in Pacific, we're going to build a logistic regression model that will help us to predict who is going to be arrested or not. Here's the procedure that we followed. First, we train our data in 2011 data. So we consider all the stuff from 2011, and we try to predict who is going to be arrested or not, given that that individual is stopped, based on all these 20 reasons that you guys saw in the form. So we are only considering the reasons that are legal for an officer to stop someone. Then we are testing our data based on 2012 data. So we are not using same year data, so we're not cheating. So we're trying to predict what is the possibility of someone getting arrested based on immediate information that a police officer have right before they stop someone. Then we just take the individual who have a higher likelihood of getting arrested and rank them based from highest to lowest, so in order to get the best stops, because we want to stop those persons first. Then we just have to decide if a people exceed certain probability, we're going to stop those people. So that threshold have to be decided by city or NYPD itself. So if they decided low threshold, they will get more arrest, more stop, but there will be more social cost. If they choose high threshold, they will get less stop, less arrest, but people will be happy because there will be less stop. So that's something that NYPD or city have to decide. Here's a graph of our model. So as you can see, the x-axis is stop ranked from highest to lowest in percentage based on our model. And the y-axis, you can see percentage of arrests out of total arrests. So this all stop are conducted through stop and frisk in 2012, and this all arrests done through stop and frisk in 2012. So if you just see 25%, that means these 25% are the best most stops. They have the higher probability of getting arrested based on our model. Just to give an example, if we just choose 0.03 as our threshold, that corresponds to 25% of stop, and that 25% of stop give us 56% of arrests out of total arrests. So this is pretty good because we just have to stop 25% of the people and getting quote unquote 56% of the criminals. And to compare that, if we just select random stop out of the current stop that NYPD is using, we would have get only 25% of arrests out of 25% of stop. So compared to this random selection, our model is doing far better job.
Hello. So in this part of the talk, we'll focus on the determining the simple rules that I will refer to as heuristic model that will help us to improve the stop decisions made by the police officers. So first, let's look again at the logistic regression model that Afzal was talking about before. And we see there are 20 reasons that determine the likelihood of a person to get arrested when a stop is being made. So to make a decision, to calculate the probability, we need to add all of these numbers up. But it's not as easy as it sounds, because to calculate the sum in one's head is going to be hard. So the solution to this problem might be a phone application that will do the computation for us. But then the question is, how do we interpret the numbers that we see on the screen? So that's why we need to come up with simple rules that will be easy to implement and use in the future. So to do that, first we will eliminate the coefficients that correspond to the reasons that are referred to other, because they don't make sense. Because police officers can use that reason for anything. Then for every positive coefficient that we've seen in the previous slide, we will set the value of 1. And to the negative coefficients, we will set the values of zeros. So since these are our values, 1s and 0s, this model can be easily implemented as the checklist. So here's our checklist, and we see there are 9 reasons that police officers might use as a guideline for the decision making. So for example, let's say police officer observes a suspect, then officer checks as many reasons as he or she thinks are applicable to a particular situation, and then they calculate a score from 0 to 9, which is extremely simple, and then they make a decision. Sounds good in theory, but now let's actually see how this works on practice. So to do that, we need to evaluate our heuristic model. First, we will look again at the full statistical model, the one that Afzal was talking about before. And the curve on the top represents the full statistical model. And the 45-degree line tells us the percentage of the arrests that we make if we select stops randomly. And to compare how our stop heuristics perform, let's overlay this graph with a heuristics model. So the numbers that you see on the screen are the heuristic model. And for example, you see that for 2 reasons checked, 2 reasons from that checklist that we've seen before, we know that we're going to make 27% of the stops, resulting in 49% of the arrests. So what does the other 2 curves tells us? The full statistical model tells us that for the same 27% of the stops, we get around 58% of the arrests, while if we randomly choose the stops, we will make for 27% of the stops, we get 27% of the arrests. So what conclusion do we make based on this graph? We know that our heuristic model performs much better than if we select stops randomly. And at the same time, it performs slightly worse than the full statistical model. But considering the fact how easy and fast it was to get these results, we can tell that the heuristic model is the optimal solution to this problem. So in conclusion, in this talk, we focused on the social cost that the stop and frisk policy brings to the society. First, there are a lot of people who are being stopped for no reason, and there are burdens on on the specific demographic groups such as young Black males. And in the second part of the talk, we try to improve stop decisions made by police officers using full statistical model and the heuristic model. So this concludes our presentation, and if you have any questions, let us know. Thank you.